So this is going to be a pretty quick video where I'm going to kind of explain to you artificial radioactivity, which is different from natural radioactivity or natural transmutation, artificial transmutation. Those words are kind of interchangeable. It's exactly what it sounds like. It's artificial. It is occurring because something is being done to an element that is stable or slightly unstable, but not unstable to the point where it's going to decay on its own. So the definition of artificial radioactivity is bombarding the nucleus with particles. So we take an atom or an element of an atom, we take a particle, one of the ones that we've talked about, or some others that you're going to see, and we smash them into each other. High-speed velocities. If you've ever heard of a particle accelerator, or I think they're called hydrogen tunnels. I might be making my own terminology up, but it's basically these mile-long tunnels where they shoot particles all the way through it and make an atom and a particle collide. This is how we get those elements that are higher than atomic number 92. They're going, and as you can see here, this is something like beryllium, so it's got the atomic number of 4. So it doesn't have to be heavy particles, but that is how we make heavier ones in some cases. You take two, you smash them together, and you make a bigger one. And there are two types of artificial radioactivity, but this is just a general overview of it. We take beryllium, we smash the alpha particle into it, and we get a transmutation reaction to occur. The products are different. It depends on what was smashed into the element that determines if it gets bigger, if it gets smaller, how small it gets, if it breaks into two different elements, and we're going to kind of see all of that in the coming days. So that's just your basic definition of artificial radioactivity. It's very different from natural because natural is spontaneous. Spontaneous meaning it happens on its own. It goes by itself. Here's the atom. It's just sitting there. It's chilling. It's unstable. And then all of a sudden, it's radioactive. That's a natural radioactive decay. The artificial is having to taking two particles and smashing them together and seeing something happen. So that's the big difference between the two, natural and artificial. So there are two versions of this, and the first one is called fission. It's the first type of example, and basically what it is the nucleus of an atom splits into a smaller nuclei, and it releases energy. And I'll get to that in a moment, but we take something that's big, and we break it into something or two things that are smaller. And it's kind of, the word fission or fizzle, or to me, it always sounds like breaking apart. Like when something fizzes, it's kind of fizzling out. It's burnt out, right? So it kind of just decomposes and breaks down. So when I hear fission, that's kind of the thing that comes to my mind is breakdown, the diminishing of something that's big. In this case, which doesn't happen in natural radioactive transmutations, is we take some of the mass from this atom and we convert it into energy. So we take this big atom, we take this big atom, we smash something into it, it breaks into something smaller, but at the same time it gives off energy. And this is the first and only time in our curriculum where we're going to defy the law of conservation of energy. The amount of energy you start with is the amount of energy you end with, except for in fission and when we are going to learn about fusion. And this is where nuclear waste is produced. So if you've connected the dots, I know all of you, because we live pretty close to one, know where fission is taking place. It happens at power plants. The Indian power plant, or any power plant really, produces a ton of energy that the entire small tri-state area is using, instead of having to use oil and create fossil fuels. Um, the exception, or the catch to that, is that there is nuclear waste produced. I'm not going to get into like the whole political thing, but depending on how you deal with that nuclear waste, it can actually not harm the environment if done correctly. But anyway, here's an example of a fission reaction, and there's a lot of stuff going on here, so I just want to break it down for you kind of quickly. This is uranium-235. It is radioactive if one neutron is smashed into it, and that's what I'm showing you in this little picture here. A neutron smashing into the uranium-235 atom. When that happens, we see a splitting of the uranium into five different particles: a krypton, a barium, and 3 neutrons. This is fission. A big atom artificially decomposing because a neutron is banging into it, fizzling or decomposing into 5 particles, getting smaller. And it's kind of a chain reaction, because what happens is once one uranium atom is hit with a neutron and 3 neutrons are released, those 3 neutrons will be released and find their way into other uranium atoms, and other. Just like before, if we were to, and you're going to practice this if you haven't already done it in the last lesson, all the top numbers and the bottom numbers are going to be the same. And that's kind of how we balance and figure out what is what. Big thing to notice is that this 3 in front of the neutron is a coefficient, right? So it's like the moles of neutrons, and it carries over into the sub numbers. So the 3 neutrons, even though one neutron has a mass of 1, there's a total of a mass of 3 and a total of an atomic number of 0. All right, so that's fission. Power plants creates a lot of energy for us to use. The other one is also something that creates a lot of energy, and it's called fusion. And it happens in one very important place, and that would be on the sun. That gives off a ton of energy, right? And it's a perfect example of artificial, 2 particles smashing into each other. Some of you might say, but the sun is natural, so how can that be artificial? The artificial comes into the fact that there are 2 particles that are colliding. It has nothing to do with where you really find it, but how it decomposes. Natural is one thing, breaks down. Artificial is 2 things collide and react. So fusion is a fusing of atoms. And when things fuse together, they go from being 2 small things to 1 bigger thing. It's exactly what fusion is going to show us. We take these smaller nuclei, we fuse them into 1 large nucleus, and there's a tremendous release of energy. All right. Mass is obviously converted into energy again, and there is no nuclear waste in fusion. So those are just a couple of things. The more important thing is to really hit the nail on the head with that. You take these 2 particles, you put them together, and they make something bigger. And that's really what I've got for you for this lesson. And so you got to know the difference between fission and fusion. Fission is, again, I'll repeat it just because repetition is good. 2 particles colliding and breaking apart. It's fission. Fusion is 2 particles coming together and getting bigger. But again, in both situations, there has to be 2 particles colliding. That's what makes it artificial. So that's it. It was a nice, quick, short one. I'm gonna upload some other stuff for you to try and practice and work on, and I'll catch you later.